right. Hey, we come back here to the video talking about the raw data in your lab report. Pay attention to every single details, because I guarantee you, if you follow every steps I tell you, there's no chances of you getting any points off out of the raw data. So let's look at this one. What is the raw data? There's two sections, as I mentioned in the previous video. One is about the quantitative and one is about the qualitative. Look at the quantitative here. It's all about the numbers that you're picking up from your lab report. Now, when your lab experiment, when you get these data, you're going to have to put them in some kind of table. In that table, it has to be very organized and it has to be in the form that it shows the independent and the dependent. So every tables that you have, they should have full sentence titles, okay? In that sentence, you should mention your independent and your dependent. Make sure all the units are inserted there. We are going to look for those units. If you're missing out on a unit, or if you're missing out on uncertainty, you got points off. That's how pained about we are. We're going to pick on that. Never ever cut a table. So let's say you are on the end of a page 3 and your table, it's moving on. It's passing on to page 4. When that cut happens, you have to put, again, the entire titles on the top. Whatever it is in your table that is titles on the tops, they have to be redone again. So it is very important that you don't do that. It's better if the entire table is in one page. But be careful not to waste, pages on that. But again, the more clear and neat, the better it is your points in there. And of course, the last most important is I see a lot of kids putting the average in the tables. Do not put the average in the table. Raw data has no calculations. It's just what you get, what you see on your lab report, and that's it. So let me show you an example of a perfect table that we will see here. In this thing, you can see that on the beginning of the top, you have the title, which is the effect of different temperatures on the rate of photosynthesis of a plant. You notice it's a full sentence mention both. That's the title. The tables have to have titles. Then right under the title, you will have the dependent variable. So yes, you will see the independent on the corner and the dependent on the top. Always do this. Independent, dependent. Keep that in mind. Now, when you mention the dependent, if you notice here, I'm also putting the uncertainty and the unit. In this case, we're talking about bubble. So it's plus or minus 1 bubble. So if it's mass, you'll be plus or minus 0.1 grams. You have to put the unit and the uncertainty on your dependent variable right there. And you can notice that it's the same thing that goes with the independent variable. You put the independent name, and of course, you put the unit and the uncertainty of that table. This is how you make sure that you have mentioned everything from the unit, uncertainty, and the titles of dependent and independent. Then the next thing that we have to take into mind is when we're talking about the trials. If you notice here, there is 1, 2, 3, 4, 5 trials. So there should be 5 columns, and each of these columns will be for each of the trials that you get. Sometimes you're going to have a split into 2 with like initial and final data, but it needs to be there. And then you have all the numbers in there. Now, here's the thing. Do not put the units in every single one of them. Why? Because, again, you already mentioned on these tops. Now, this is a perfect one. And it shows, again, that 25 data is that of a raw data. Again, now calculated. So, when it comes to quantitative table mistakes, let's look at those ones that we usually find. The first one is you are basically putting all the numbers and stuff like this. Remember, the key point to remember here is that without units, it's meaningless. You have to put the units in every single one of them. So if you're putting the minutes, all good, no problem whatsoever. But what happens is that students forget to put those things. What I would advise you to is that not even put these numbers here. I wouldn't even put these units here. I will put them right here. Because when you do that, that automatically means that everything that is under it will work. So another one is make sure the decimals are the same. What it means by that. If you look at this table here, the decimal has to be the same because it's all about significant features. So right here, you notice there is a 0 and then there is a 1.8. 1.8 is 2 significant figures while 0 is only showing 1. Look at 2 here. 2 is only 1 significant figure. That kind of mistakes cannot happen. You literally have to make sure that you're putting 0 here and 0.0. Why? Because the significant numbers, you notice it's always after 1. So that's 0.0. That should be in every single part of your table. So If you want to make it as a whole number, that's totally fine. But if there's a dot with something afterward, then you have to count how many the dots are. Keep that in mind. So for instance, if this was just 24 and 27 and a 5, you don't have to change these numbers, but it's all about the dot afterward. So this is an example of what you would fix a table to make sure that all the significant numbers are clear. If we see one tiny little mistake at this, you go from a 6 to 5. That's how we take points off. Just to let you know. All right. So here is about the 3 rules. The first rule is that non-zeros are not significant. What I mean by significant numbers? I know a lot of kids don't understand what significant figures is, so here is just a general rule. The first one is all the non-zeros are insignificant. However, the zeros that are between non-zeros are significant. So let's just say if I have here 63, right? And then there's a 0 before it, that's not significant. You just don't take it seriously. This shows that there's only 3 significant numbers. If the zeros are in between, like you see here, there's a 3, 0, and 9. The 0 is between 3 and 9. It's considered significant, so this will be 3 significant numbers. Now, trailing zeros are only significant if part of the decimal. You see how here it was before and there was no decimal? It's insignificant. But if they were after the dot, as you notice here on the dots, right? These ones right here, they usually are important because they're after the decimal. So these ones right here are not important, but afterwards it is. That means anything that comes after the numbers. Here, for example, you have the 0 between 2 numbers. So what does that mean? These guys, we have those 4 significant. But don't forget, there's an extra 0 that comes afterward. It is important. Only because it is after a certain dot. Here, for example, there is no dots, right? You don't see any dots. And that means all these 3 are not important. So the dot makes a big difference. Any zeros after the dots, after the numbers, of course, and after the dots, then that's a spirit. So this is how you find a significant figure. This is a very quick general idea. But you have to keep that in mind. This is something you learn in math, but just refreshing your mind here so you know how to do it. Now, when you talk about significant figure when it comes to calculations, well, how do we do this? Well, right here, you can see there's 4, right? It's all those 4 numbers. There's 2. So how would you get in the end? You go with the lowest number. Why? Because it was 2. So in the end, 2 and 8 is the only one that is significant numbers. Same thing with the divisions. You had one that had 4, had 2. In the end, the lowest number. You take 5.4. That's it. Additional. Here, you can see that you're only using the decimals on the corner. So what do we do? In the end, we are getting the full number, and that 0, that 1 over there, it's actually taken off. Same thing here. We add addition to this, and what's going to happen? There is no points after the dot here. So you round it up to whatever it is. This is how it works when it comes to addition and subtractions. Once again, we are going to look at this. It's very easy, simple. But just remember that if you on your chart, you have 2.57, 2.5, 1.5, and then you have 1, make sure you put that 0 under it. But if any of them is just, for instance, if any of them come out to be like 3 and a 4 and a 5, you don't need point zeros. Not at all. But what if you have these and then you have 0.1? Then my advice is anything that is below 5, it stays 5. If this was 5.6, then you round up this to 6. But I barely see this because it's impossible in an entire lab that you have that you're going to have just one that has a decimal and everything else will be round. It's very, very rare. So make sure you're looking for that decimal number and to see the significant numbers whenever you're doing your chart. Next, let's talk about raw tables versus the process table. Here is an example of what we call as calculations going on, but which process does sections in this? Just to make sure here that when you're doing a table for raw, you don't see any calculations here. You just see the numbers, right? You see the experiment here and you see the raw number with its title. You don't see any calculations going on. Many students, what they do is they put the average. You see here, we have average. That is a process section. So when you go back to the raw data, this is the only thing that you mention. It is the raw data. The moment you're doing average, this is a table, this is already a process table. Please keep the process table to the process section. Don't put it on the raw data. Now let's talk about certainties, since we have to put the uncertainties in your raw tables, right? So right here is an example of how we can calculate uncertainties to help you out. Right here you have a tennis ball and you have the ruler. And of course you're trying to measure this ruler by looking it up, and we're doing from this point with this point. And okay, and you got an estimate of 25.0. But usually we'll say 25. Why did they put the 0.0? Because you will look at the measurements right here and you can see that this has to be according to whatever the ticks are. So, for example, what is the diameter of a tennis ball that has these guys? Which result is the right one in this case? Obviously, you have to look at the ticks. When you talk about the ticks, it's all about checking the numbers here. If you see that it's going to fall in between two ticks, that means it's a 0.05. So in this case, it would have been somewhere at this one or maybe this one, depending on the situation. But we're going to look more on the next slides just to get you a little bit more detail of this. So here is just to give you a little bit more scoop of how you can do this. So you have a ruler here, and if you look at this rule on the top one, it says 2.55 because it's right middle, right? Between 2.5 and 3, basically it's right here. And then right here, you don't see any ticks, do you? There's no ticks in here. So you can't put that 2.55. It's impossible because you don't know. So if you look at these two, obviously this one is a little bit more precise than this one is just generalized. So there is an estimate that you can put on this ruler A here. Why? Because there is a ticks that helps you give you that extra edge. So let's say here, this is a 2.5 and it's between 2.5 and 2.6. So there's an additional, let's hear 2.5 tick, and this is a 2.6 tick. And you found something to be right in the middle. So it's between those two. So you will be 2.55. That's how you get the significant number in there. So in this case, you can see that you adding an additional 0.5. That's an uncertainty right here. When you look at the bottom one, you have a 2.5 and a 2.6, but there is no ticks, and you don't even have those ticks. You look at this and you don't see a 2.6 here at all, right? You don't see a 2.6. So you can't really estimate anything about it. So if there's no ticks whatsoever, most likely this would just be one estimate out of the whole thing. That's how you need to make it work. So let's look at some examples again, just to practice it out here. So the ruler here, if you notice ruler A, it has less ticks. So in this case, for sure, it's going to be around 4.2, right? Because it's right laying right here. But if there is ticks, that means you can go even more precise. So it might fall between the two ticks, as you can see here. Then you'll be 4.25. You have the additional one. So how is the uncertainty of these guys? In this case, the uncertainty will be plus or minus 1 for this. And this one will obviously be plus or minus 0.01. Why? Because of this guy right here. Now, it can be 1 or it can be plus 0.5 if there is no tick for that one. So it's up to you. But again, you have to put the uncertainty for every measurement that you do. So here is another example. Again, let's practice to make sure that you really got this. So you have a 565 gives that it's a 0.05 centimeters. Then if this is this, what would it give is this one. And if this is this, what would it give this one? Does that make sense? Why am I using here a 5, right? And this time I use the 1 from the previous video that you saw, the previous slide that I was talking about. Simply because, again, that 0.05 was because it was between two ticks, right? There was two ticks and there was no extra tick in the middle, but you notice that it landed here. So you are assuming there is that 0.5 in there. That's why I would stay with the plus minus 0.05. Now, here on this one, I only put 0.1. That will be that there is ticks right next to each other, and you landed on this, and most likely you're going to land on the next one. So it's just a plus 1. So it really is up to you. Remember, if it falls in between two ticks, you get the extra 5 in there. And if it falls on exactly the ticks where they're precise, then just go with 1. That's how I would take it as a rule. But many teachers and scientists will use different types of uncertainty units. So you just have to make a better judgment of which one you want to prefer to go with. But I would advise, if it falls between two ticks, go for that 5. And if it falls on the tick, then just go 1. So here is when we're using graduated cylinders. Graduated cylinders, you will ever notice that there will be a line going down like this. And that line is basically making a reading. Now, you have to get to the level of it. So if your beaker is right here, you need to go down, bend yourself, and make sure that your eyes is on that level of that water. Why? Because this is how you're going to know exactly where that water is landing. Don't look downwards, because that's not going to work. So here you have different types of equipments. Now, what's important for you to understand about these equipments is that the more precise the tick, the better the equipment is. Like if you look at these guys, they all have the same amount. They all literally have the same amount of liquid. But if you look at each one of these beakers, which one would you use? I prefer this one because this can be more detailed. This one, it's too generalized. Also, this one, it's probably generalized. This one, I might even use it because it shows more in the line. So remember, the more precise with your beakers and ticks, the better it is. But again, which one of these guys, how would you do the uncertainties of this? Obviously, you also have to look at the rules for that. So here's a meniscus. See, your eyes have to be according to this line, and this is where you put in your mind. Now, in this tick, this probably is, 35, right? That's what the number you're going to get. Now, what would you put as a thing? Plus or minus 1 milliliters, because it landed on the tick. If it landed in between the ticks, then I will say 0.5. It's up to you. All right. Here is again looking at these measurements. What would be the uncertainties for these guys? Straight up written for you. Don't need to do much of a mess. For example, in the 50 milliliter beakers, you will use about 2.5 millimeters. If you're using let's say this is a 30 graduated cylinder, then use 0.5. And if you're using something that has more ticks going on, then it's a 0.05. Would I use that? Yes, just use these ones and it's good enough. You don't need to go in details about them. That will help you answer all the uncertainties of the different types of equipment. When it comes to digital, that's way easier. Whatever is the last number after the dot, that's your uncertainty. And you always go by +1 or -1. So for example, in this case, you can see that this is a 0.1, so it'll be plus or minus. So digital equipment is much easier to get to the process. You also have here, this weight scale, what would it be? 0.1, again, because that's the one that you have in the outside after the dot. That's how would you work. Now, when it comes to qualitative data is about descriptions, and you need to have qualitative in your lab. You cannot go without it, otherwise you're going to lose points. What is this about? It's about descriptions. It can be about the scent, the color, the stage. Is it solid? Is it liquid? The texture and the contents. Whatever, you can see here different names. This is descriptions of your lab. Can it be just a chart with words? Yes. Can it be pictures? Yes. But if you put pictures, there should be descriptions about these pictures. You can't just put pictures as your qualitative data. Now, this is an example of a picture that you can put it here. Now, but you notice that they're actually giving information here. But is this enough? No. You have to have a couple sentences describing what you see. Oh, it's green, now it became brown. Or the leaves were smaller, now they got bigger. Or we can see more stomata on this and not stomatas on that. You're describing it. If you just put pictures of qualitative data, that will not be enough. You really need to make sure that you're explaining more details about those pictures. So is the best way to do a chart? Yes, you can do charts in which one column you put the pictures and the other one you actually have the descriptions. It's up to you. But as long as you are not cutting those charts into the next page, if you do, then you have to put the titles again, saying pictures and descriptions, whatever it is. So this is the part of the raw data section. We talked about the quantitative, we talked about the qualitative of the raw data, then everything that is related to it with uncertainties, units, the way you describe the tables, that's the raw data. On the next video, we're going to talk about the process data and all the important things that must be in your process data section. So go ahead and go for the next video in which I'm talking more details about the process data, because I know a lot of you guys have an issue on the process section. And just remember, with NAILB, you can get that 7. I guarantee you. See you later.